Hi guys, it's Frankie here. In case you haven't been wandering around, this is the data empathy session. So we'll get right into it because I've got a strict time limitation here. So let me talk about a little bit about myself. Um, I'm one of the co-founders of Hivery. It's an AI startup. So a lot of this stuff I'm showing you today, it's actually proven. It's actually stuff that we've used in the past and are using at the moment. And so prior to Hivery, was part of an innovation program that driven by Coca-Cola, and before that, also innovation and design thinking in AMP. So today is really about building data empathy, and it's a first stage in order for you to develop an AI solution, whatever that is, from robotics to a software app, a web app, to just an algorithm that you want to train and so forth. And so in order for us to build data empathy, we use a framework, and this framework I'll be showing you. So today you can, leave this webinar and get an understanding of how to start your own AI initiative and have a framework in mind. And so that framework we're going to go through is this, what I'm calling the data empathy canvas. And it's actually based on a design thinking canvas when they go out and build empathy to customers or users. So I often call it persona canvas. So let's go into it now. So why data empathy? Well, it's important to understand why it's important to build this empathy towards data, and then secondly, also the actual application or the customer and user. So let's dive into this a little bit before going into the actual canvas. We know that we're in now what often is called the fourth industrial revolution. It's given rise to a lot of data. And in fact, they often call it, there needs to be called the 3 Vs, the 4 Vs. Now we've got the 5 Vs of data, and it includes the volume of data being created, so often referred to as big data. We have sort of the velocity of data being created in terms of like the speed by which data is being created. You think about it, any company today is a data company. It's generating data as we speak. Even you personally, as you travel on public transport, or you're purchasing something, or you're watching something, you basically elicit these digital footprint. And that's been collected somewhere in the ethos. And so the velocity of this data that's been created is just tremendous. And the third thing is variety. And so you've got structured and unstructured data. So structured is basically, Excels and your CSV files and so forth. But you also have unstructured, which is, mostly driven by, in this revolution. So you think about unstructured like your video files or your photos or image files, audio files and so forth. And so the next layer you have also is the value. So people are now starting to see sort of the new oil around how they can leverage data. And the final thing, the fifth one, is the velocity. Velocity. Basically, it's the quality of data. As you know, as data has been built, it's getting better in terms of clarity, and the quality of the data being captured is getting higher and higher. So this allows machine learning engines to actually you don't need to actually clean the data as much as before. So these 5 Vs have triggered off really because of the fourth industrial revolution. And so there's a lot of data there, and so building data empathy towards these 5 dimensions allows us to build better AI applications. So let's get into a little bit more about these in the fourth industrial revolution. So think about it, and this is a quote from IBM. IBM, this is a while ago, this is 2013, suggested that 90% of the world's data was created in the last few years. Okay, and that was 2013. You can imagine there's a lot more since then. And another report, Forrester report, suggested that there's only 12% of data actually being used. So basically, the data we're talking about here is the business intelligence units in large organizations, enterprise, large organizations that would use that data to try to make sense, trying to find patterns out of that data and derive actions. So they won't, because of the 5 Vs, now it's getting harder to leverage with traditional or conventional systems and processes. And so this is why we're investing in machine learning, and then we're also investing in data scientists to unpack those data sets, those large 5Vs. So how do we then harness this data? This brings us to the subject of this presentation around data empathy. We need to build empathy towards the data. This is the one way we can actually really gain an understanding of how we can leverage this data. So I defy, and there's a definition right here in the screen. So data empathy is a process by gaining an understanding of how the data travels through any organization, private, non-profit, profit. That really doesn't matter. We're talking about data and how it travels through the systems. How the data is actually being used, and what systems and process supported. These are important because you would find later on you need to tap into those systems and process in order to extract and have a pipeline to start training your algorithms. And then more importantly, from a business perspective, what are the decisions derived from this data? And so data empathy is about capturing that in essence. And so in order for us to develop and gain this empathy, we create a data empathy canvas. Again, like I mentioned before, it's a framework. It's a framework for us to think through the dimensions that we need to understand, unpack before sort of diving into further with our AI initiatives. So I say here it's a first attempt, like any other canvas. And the picture there, you see someone sketching, you rub it out, you sketch, you rub it out. It's an iterative process because it's a first, basically, when you first develop your canvas, and we'll go through an example today, it's basically an assumption what you believe to be true. And so the process of a data empathy canvas and the journey we go through is actually validating, very much similar to validating a business model canvas. If anyone in the startup world would know what that is, it's just kind of validating the assumptions of the canvas. So let's dive into a little bit about what that canvas is, the framework that I'm representing. Nothing complicated. There are really 4 sections. And the first section is around goals. AI is pretty good. But you really need to define your goals very well before you begin any initiative. Now, those goals, typically from a business perspective, is around a commercial sort of outcome. But nevertheless, there's other non-commercial goals, but you need to define those clearly. And we will go for an example. Then once you define it, you say, well, what kind of data sets are available for me to actually capture and train my system to realize that goal that I've defined? But you can have the goal, you can have the data rule, you can have the data sets, but if the recommendations by the algorithm are not practical and it can't be implemented in reality, it's no good. And we'll go through that, and that's all about rules, or often called in machine learning constraints, adding constraints. And the situation is the final aspect, is summarizing up what our initiative is about. Our first understanding, like I said, it's a iterative process, but this is what we believe we're going to solve. And it's a great tool for using for stakeholders to get them on board of what we're going to achieve, because getting clarity is going to be a key focus in this canvas. So I want to do is really dive into each of the components so you get an understanding of how a data empathy canvas can be used in your own initiatives, in your organizations across whatever industries that you're working on. So let's focus on goals, because like I said, it starts with goals. It all starts with goals. So let's dive into this. What is goals really about? It's about providing focus and clarity in terms of what needs to be done or solved. What do you want the AI to do? Basically, that's the question. And it also provides clarity with stakeholders around who are involved with this project. So importantly, goals can be then broken down into sort of automation goals or learning goals. This is a type of algorithms you're going to potentially use. So automation goals is like, hey, there's spam is in a way, detecting spam is in automation goal. Or in finance, you probably be doing things like approving home loans or credit cards using AI to determine risk profiles, the automation roles, right? There's also sort of a learning goals, where learning goals are what we do actually at Hivery. It's basically a recommender systems where it learns and starts projecting out recommendations. And not necessarily, it's not about saving costs, really. It's about driving revenue in a sense. Learning goals can be used mutually exclusive or together, but typically they fall into those buckets. Maybe there may be others, but generally speaking, the automation, you want to reduce costs, or drive, you want to use the algorithms to learn new insights, new recommendations, which is your learning goals. Like I said, they're typically, for us, it's the recommender systems, the Amazons, where it recommends a book. When you buy something like this, it recommends something. That's your sort of your learning. It's learned the behaviors of past users, and then it starts recommending. But also, what's important about goals, for the first time, we can actually translate these goals. This is where data scientists come into a data science question. So I said we're going to go into an example, and we're going to do one with vending machines, because that's how we started with our company, with using AI in vending machines. So let's assume that you're in Japan. You've got 5,000 vending machines across Tokyo, and you want to basically drive what? What is the ultimate business goal here? I mean, it's no secret, right? You want to drive profit. But then profit is driven by a couple of factors to combine profits. And that includes, you want to reduce costs. So basically, I want to reduce my restock visits and out of stocks, but I also want to increase my revenue, which is basically how do I increase the value or the products that have been sold in that product. So they're kind of your ultimate goal, right? You have 5,000 vending machines, and ultimately the goal here is to drive profit. It could be others, like I said, but in this example, let's just say it's profit. But what makes up profit in this case? Very simple. There's other elements, but let's say you assume you want to reduce costs, no brainer, and you want to increase revenue. And the driver for cost is to reduce my restock visits. That's the key one. And in terms of revenue, I want to increase product sales, which means I really need to find out what products should be in what vending machines. And so let's dive into this example even further. What happens is that now we have sort of our two business goals, which underline the ultimate goal of driving profit. We can actually translate those two dimensions into a data science question. So in this case, if I want to reduce my costs, i.e. reduce my restock visits, the data science question, which is a data science scientist with a commercial lens, would say, well, what is the likelihood or likely capacity of this product in each vending machine? So if I got a product and I've got a lot of vending machines, what is the capacity of each? Which is basically, if I've got more capacity, I can go there and fill it very well. I don't have to visit much. So that's the driver there. The next question is around revenue, right? Well, next, from a data science question, it's what is the probability of product X selling in that vending machine? So this is where machine learning is great, is that I can predict what would individual products sell to individual vending machines and come up with an optimized assortment. So now you see we have the goal, which is drive profit. There are two fundamental drivers, cost and revenue, and then we translated it into a data science question. So let's go further in this. What happens now, we've got something abstract like a goal into two drivers into a data science questions, but now we start to understand what type of data sets are needed to address the probability and the capacity question. So we're going to go in and add this into our data canvas. So that's our first attempt of what we believe is the goals and the likely data science questions that we need to answer. So now it sets up very well to what are the data sets we needed to address those two fundamentals, the ideal capacity and the probability, which are linked back to the goals of the vending machine example. So now let's focus on data. What are we talking about in data in terms of building that empathy? Well, there are four dimensions in data that we need to consider. The type of data. So now it's okay, what is it? Do we need to, if we remember those two things, probability and capacity, what information sort of type on it? Is it sales data? Is it product data? Is it promotion data? Is it column data? Is it machine data? Location data? So that's one type of area that you need to consider. Next one is quality of the data. We had examples where when we went into a vending machine operator and the system said it had Fanta, but in fact it had Coke. So huge integrity issues. So we need to make sure that the data integrity of the systems, remember, back to the definition, the systems where the systems support and derive that data, it has integrity. Next one is quantity. Well, I need enough data to our algorithm. So another question that we need to consider. And our final thing is flow. Who are the owners of this data? Is it external, like proprietary data, or is it internal? Because then I need to influence and secure that data to continue to try and recommend, to access and train my AI algorithms. So 4 fundamentals, and that's part of the data only. So back to our question here, that we have ascertained that we want to reduce costs and we want to drive revenue that will increase our profit. We ascertain also the 2 data science questions, capacity and probability, which are drivers of that. So the next question is, well, what kind of data sets, I said that illustration is, what kind of data sets or systems I need to go and find what is possible, what I said here, likely to address those 2 fundamental criteria, capacity and probability, or cost or revenue. So here are a list that we went out to our internal stakeholders, to system owners, to our domain expertise, people in the organization, or like say you're the vending operator, go, yeah, I have product ID, I've got sales data, cost of goods, which is COGS. Vend price is basically the price that has been vended. Capacity matrix, which is each product, each vending machine, I've got data of that in terms of sizes, and I've got details of where the vending machine is located. Great. So now there's a first attempt likely that we might use all those data sets. So what we're going to do is plug those data sets into our canvas. So now we have a clear understanding of the goals, clear understandings of the data, data sets that we need to extract and train our systems and see how it go. The next thing is, how do we make it practical? And so practical as in implementation of these rules. Are there anything that the AI model needs to consider before it makes these recommendations? So let's dive into rules. So everything's driven by rules. And you can see a picture here of Wally. Wally was driven by rules in terms of what he had to do every day, day in. But even autonomous cars, think about it, there's rules about traffic signs and lights. Think about Google Maps. We all use Google Maps. And so you think about it, if you want to go to A and B, a rule or constraint is avoid toll. So, Google Maps will optimize that path, but ensure that it abides that rule of avoiding tolls. And so we have rules in all things with this. In our case, we have rules as well. So one rule might be that for in particular our US customer, when we were doing this vending stuff, we couldn't sell sugar drinks in vending machines at scale. That's a rule. So when our recommendations were providing for a vending machine that is located at a skill, it would do the optimal planogram or the picture of what that vending machine look like or should stock, but without sugar drinks. It would determine the best likely product to be sold, like waters and juices and milk and so forth, in that vending machine. So that's a rule, right? But there's heaps of other rules that you need to factor in. And what rules do, like I said, is make the AI recommendations practical and operational in the field. And that could be for robotics, for self-driving cars, in this case, vending machines. So we also maybe have other more operational, could be contractual rules that you need to enforce this. So these are the ones we might include operational ones where I said, look, only change, if you're recommending any products in my vending machine, I don't want to change the whole vending machine. I just want to replace the two poor performing with your recommended top 2 products to put in the vending machine. That's one operation rule that we need to then in. That's true, right? Because you might fall back on it. If you optimize a vending machine so well, you might visit every day because it's selling well, but then you have to restock the system every day, which increases your cost. So this is an important rule. Another one might be that you have a contractual rule that you don't drop volume being sold of a product more than 15%. So you want to increase price, revenue, but you don't want to increase, because if you increase price, demand will drop, but you don't want to drop it too much that would mean people won't buy that product that you're having in the vending machine, because contractually you need to sell certain amounts per month or per week. So there are a couple of rules. So what we're going to do now is actually plug those rules into our canvas. Now we get clarity. We have clarity about the goals of the systems, the data science question, the data sets that we're going to explore, and also the rules that we need to consider. So now we can actually go to our stakeholders, remember back to focus and clarity. This is what we believe, or when I said believe, it's the first attempt of what we think we're going to solve in the data sets and the rules that we need to feature engineer. So this leads us to nicely to the last section, which is about how do we sum up this? What do we do to actually articulate the solution or the first, the algorithm that we're developing? So let's dive into this a little bit. So as you can see in the photo right here, the situation is really around building clarity and a focus around the project. So now, like I said here, what the business goals are. So for the first time, we've ascertained what the business goals are. We also ascertain through having this documented the opportunity to identify any risks or challenges. An example is with one of our clients in China, for example. They were very keen to use AI. And they were rolling out these vending machines. But if you're rolling out new vending machines, you don't have data. And so there was a challenge there. We had to actually wait several months to have enough data and the quality of data. So by documenting the situation, what we believe, we can start looking at what are the other dimensions that are being considered here. And so for the first time, we've got this ability to see we need to go back to the canvas and say, well, we can't do this now. We might need to change the goal, for example, because we don't have the data at the moment. But the other point here is around clarity, clear direction. So the data scientists know what's the project about. The engineers ultimately down the line, when they start building this into an interface or into some type of application, know what the situation would be and what it requires in terms of effort and resources. And so the last thing is more about, moving from R&D, research, but to much more project management. So now from the situation, we can ascertain or summarize resource planning, developing all the formalities, so like project plans, communication plan, change plans. And if you're doing for a consultant, like a consulting gig, you can develop a statement of work in terms of what this would look like, who we're solving for, the goals and so forth, and what are sort of dependencies of this project. So that's a situation. It brings it together. In our case, we can actually do it in a one-liner, right? And so we can summarize, again, it's an iterative process. We might get back to it and say, no, that's not exactly the situation, but we definitely agree on the rules and the data sets that we need to explore, and the goal definitely are it, but the situation needs to be refined. But for the sake of our example about vending, we can say the situation can be summarized by saying that develop a solution that provides product assortment and space to sales optimization recommendation in a simple interface. So that actually says a lot. To think now we know it's a product recommender system. We know we probably need in the space of sales, it's a operations research or optimization problem. And so we know we need a data scientist in machine learning engineer, but also we might need operations research engineer, which is completely different. That's applied math. The other one, machine learning is really driven from computer science. The other is from applied math. So two different disciplines. And we also mentioned simple interface. Well, that means we need definitely a UX, a UI designer to come on board, and we probably need a software engineer to help us build the first attempt of it. Like I said, this is a great summary now of this business model data empathy canvas. It's a great summary of our first attempt of what we believe we're going to solve, what is required, what are the rules, and what kind of formalities we need. So I mentioned it's an iterative process, and it's true. Like in design thinking, and also in lean startup. If anyone, like I said, people in the world there who are watching this webinar, I'm sure that you can relate that when you develop your first any project, when you first develop your project, it's an assumption of what you believe to be true, and you might get the first time right, but it requires a lot of collaboration amongst stakeholders, and those stakeholders include the domain expertise, the system owners, data scientists, UX software engineers, to start understanding what the dimensions of the first version of the canvas that is true. You might go again back to it and refine stuff. But generally, what we're trying to do, like the business model canvas in a way, is to get a sort of an assumption validated. So we might go down to, yep, we strongly believe that the gold section is 100%. That's it. That's what we want to achieve. These are the dimensions that we, that's the business driver or goal that we want to achieve. Then you might discover that after a while, you've got the data sets sorted out because you've been testing that with your internal stakeholders, your system owners. You might be an external data provider. You might add in, I don't know, weather data, for example, or social media data into this, and then you need to access that from somewhere else. But you know that these are the data sets because they answer the business question. And then you go into the final stage where you say, okay, now I've got the goals set. I have also a clear understanding of the data sets I need, and also the rules. Like I said, I can't emphasize. Oftentimes projects miss that. They go right from gold and start experimenting, and then don't forget about the rules. Rules are important. Every algorithm to make it practical and implementable in any market, like I said, from autonomous cars to robotics to vending machines, require a detailed understanding of the rules, and it could be some of the rules need to be redefined or even challenged. You might say, well, we don't need those rules anymore in this new world because we can optimize in A, B, and C. So now we might go back and challenge those rules or add new rules. The ultimate goal is to get to the point where all elements of that data empathy canvas is being validated. And like I said, validation could be running a few experiments on the algorithm and doing trials. It could be running for experiments on the data sets. You might pin a database and see how credible that is, but it might be the quality of the data you want to test a little bit before going back to the data sets or back to the business goal. It might be the whole goal itself needs to be reframed, often called reframing the problem. Like I said, this is an iterative process, and it can go back and front. But this is why a lot of times in part of our journey has been collaborating a lot with our stakeholders, domain expertise that understand the dimensions and also the challenges faced in the industry. Nobody's an expert, but when you bounce ideas, you can actually come with ascertain a great summary of what the situation or the data empathy canvas should be solving for. So I'm going to close out a little bit and what summarize in terms of what we talked about in the last few minutes we have. So really, it's about there's a lot of data in the industry in this fourth industrial revolution that we actually going into right now. And so this data, remember the 5 Vs, creating a volume, a velocity, and a variety of data and so forth. How could you overcome this? How do you harness this data? Well, building data empathy is a way, and as I've defined it, is a process of building that empathy towards data. And a data empathy canvas is actually a tool or framework to get us thinking about the dimensions, and maybe more in the future. We might refine that further, but to simplify it is really understanding your goals, understanding the data sets that are related to those goals, understanding the constraints or the rules that you need to factor into the model that you're going to create it, and then summarizing the situation so you can articulate that situation or the goal of the project to your stakeholders. And that, again, on the fourth point there, it brings around focus and clarity. But like I said, it's an iterative process, and like you might get it right the first couple of times. You might go there for several weeks. And in fact, one of our projects, we did it for a month or two. Even getting the definition, in this case, was a trade promotion. How do you define trade fatigue, promotional fatigue? And it was short fatigue. And so that's the data empathy canvas. And I have links. I have a Skillshare if you're interested in learning more about data empathy and running through this type of course in detail. So if you look at tinyurl.com/data empathy, you can dive into this course a little bit further in it. And there's also, if you want to connect with me personally, please do. I'm happy to share any of my thoughts or questions that you might be asking. But like I said, it doesn't stop there. You need to other areas that of this journey is building the team, your data scientist, project management, UX designers, your core team, and then your wider team, building experiments on AI and so forth. I hope that was useful. Again, connect with me when needed. Thanks very much for your time, and I'll see you next time.